Hi everyone, welcome. Today I came with a still design for a beam, and this problem is important from the PE exam preparation. So this problem will be a very good help for those who are preparing for PE license exam. Here, as you can see, a beam is simply supported. There's a live load and dead load, which are uniform loads. And it says select the economical beam that complies deflection criteria for floor beam in the IBC or whatever it is. But it says get the economical beam that complies the deflection criteria for these loads. So I'll just go with a basic outlines. So first of all, we compute the design load. As you can see here, there are LRFD, which is load resisting factor design, or ASD, allowable strength design. We can use either of those, but I'm gonna explain more on LRFD. So, but still we will have ASD solution on side by side. So first step is to compute total load. So 1.2 is factor for dead load and 1.6 is factor for live load. So we will use these factors to get our design load. And the design moment is simply because it's a simply supported beam, so it's WL square over 8 and we get our design moment. And now based on the design load and design moment, we're gonna select our section. Since it says select the economical beam based on deflection criteria. So we will see the maximum allowable deflection for live load, that is L over 360, and the deflection we get is 1 inch when we plug the value of length. Now, since this is deflection for live load, delta L is live load, and it is a service load. Deflections are computed only for service load, not the factored load. So we can use this deflection to get our section property. Since it's a simply supported, the equation is 5WL for 384 E delta L. We can get this equation in any codes. Um, you can easily find that, and using the delta L value here and other properties, mind it again, W is service load, not the factor load, we can get a section property of 440 um, inch to the power 4. And also we can check the section property for total load. So for total load, deflection criteria is L over 240, which gives us 1.5 inch. And when we use this formula, we will get the section property or modulus of inertia, that is 420 around inch to the power 4. But here the larger section governs. So out of these two deflection criteria, uh, the live load deflection with section modulus inertia is 440 inch cubic for it will govern. So we need a section that has or that exceeds this value. And now we also check like the plastic modulus or plastic modulus of this section, which is simply m equal to fyzx. We know fy, we know mu, which is we already calculated. So gx, it is easily computed and the value is 44.4 inch cube. So what does it mean is we need to have a section that have plastic modulus equal or greater than 44.40 cubic inch, or plastic mod and sorry, it's not or, it's and modulus of inertia 440 inch to the power 4. And also what it says here is the full beam is laterally supported for its full length. So its unbraced length is 0 because it's laterally supported for the full length. So this CV value equal to 0 if your unbraced length is, that is greater than that specified for this particular beam or this section, then your CB value will change, and that will come for other problems. For this problem, CB equal to 1. And now we will go to the AIC table and we will select couple of sections. So W14 by 30 is one of the lightest sections which has plastic section modulus greater than 44.4 cubic inch, which is 47.3. The moment capacity is 177, which is greater than what we computed, but the moment of inertia is lesser than what we have calculated. So this section doesn't work. So now we go to AIC table, see other section, and we see here W18 and by 35 works. It has plastic section modulus is 66.5 cubic inch. The design moment is 249, which is greater than what we computed. 166.5, and the moment of inertia is 510, that is greater than 440. So all values are greater than what we have calculated. So the answer for this problem, the lightest and economical section, is W18 by 34. And also it says the design of the member is controlled by deflection rather than by yielding, because yeah, the problem already said get the economical section based on deflection criteria. That's how this member is controlled by deflection. So this is the solution for the problem. Thank you.